of interconnected components, technologies, and processes that work together to meet the energy needs of society. If we take an example for understand the energy systems, for example, consider a typical electricity grid of a city. Energy is produced at power plants, which can utilize various energy sources such as coal, natural gas, nuclear, hydroelectric, solar, or wind. For example, a coal fired power plant burns coal to generate steam, which drives turbines to produce electricity. The electricity generated at power plants is transmitted over long distances, high voltage transmission lines to substation. This substation step down the voltage for further distribution. From substation, electricity is distributed to homes, businesses, and industries through lower voltage distribution lines. Transformers are used to further adjust voltage level for specific application. Electricity is consumed by various end users for lighting, heating, cooling, industrial processes, and other purposes. Throughout this process, feedback mechanisms such as smart meters, sensors, and control systems monitor energy flow, demand, and grid stability. This information is used to optimize energy production, transmission, and consumption in real time. Importance of efficient energy management. Efficient energy management involves optimizing energy use across all aspects of operations, from production process to facility management. It is essential for organization to maximize the utilization of resources, minimize waste, and reduce environmental impact. Effective energy management can lead to various benefits, including cost savings, improvements, and enhance overall performance. For example, let us consider a manufacturing company that implements efficient energy management practice. For example, by conducting energy audits and identify areas of energy inefficiency, the company discovers opportunities to reduce energy consumption. They invest in energy efficient equipment, upgrade lighting system to LED, and implement the automated controls to optimize energy usage. As a result, they achieve significant cost savings on energy bills, leading to improved profit. The manufacturing company recognizes the importance of reducing its carbon footprint and environmental impact. Through energy management initiatives, the transitions and renewable energy sources such as solar or wind power for electricity generation, they implement recycling program, optimize transportation logistics to reduce fuel consumption, and adopt sustainable practice throughout the supply chain. These efforts contribute to a more sustainable operation and align with corporate social responsible goals. Efficient energy management not only reduces cost and environmental impact but also enhances overall operational performance. By optimizing energy use, the manufacturing processes become more streamlined and efficient. Equipment downtime is minimized, production schedules are optimized, and product quality is improved. This leads to increased productive, higher output, and better uh, in the market. So there are two types of energy sources, renewable and non-renewable. We in the previous lectures we already discussed both renewable energy and non-renewable energy sources, but we again discuss this topic. Renewable energy sources are those that are naturally replenished, and non-renewable energy sources are finite. For example, if we take an example of solar energy is harnessed from the sun using photovoltaic panels or solar thermal system. PV panels convert sunlight directly into electricity, while solar thermal systems use sunlight to heat water or other fluids for various applications. For example, we take an example for understanding the solar energy. Rooftop solar installation generates electricity to power household appliances, reducing on-grid supply electricity and energy bills. And second is wind energy. Wind turbines convert kinetic energy from wind into electricity. Wind farms consist of multiple turbines placed on in locations with high wind speeds. We take an example for understanding the wind energy. A wind farm located in an area harnesses strong ocean winds to generate clean electricity for nearby communities, reducing carbon emissions and reliance on fossil fuels. And third is hydroelectric energy. Hydroelectric power plants generate electricity by harnessing the energy of flowing water, typically from rivers or dams. Water is released from reservoirs to drive turbine connected to generators. Okay, now we take an example for understanding the hydroelectric energy. A hydroelectric dam on a river provides us steady source of renewable energy to power homes, businesses, and industries in the surrounding region while also providing flood control and irrigation water. Fossil fuels, fossil fuels such as coal, natural gas, and oil are formed from the decay remains of ancient plants and animals. They are burned to release energy for electricity generation, heating, transportation, and industrial processes. We take an example for understanding the fossil fuels. A coal-fired power plants burn coal to produce steam, which drives turbines to generate electricity for the grid, contributing to air pollution and greenhouse gas emission. Nuclear energy, nuclear power plants use nuclear reactions to generate heat, which is then used to produce steam and drive turbines to generate electricity. For example, a nuclear power plant utilizes controlled nuclear fission reactions to produce large amounts of low carbon electricity, supplying the significant portions of the energy needs for a country power grid. Biomass energy. Biomass refers to organic materials derived from plants or animals, such as wood, crop residues, or organic waste. Biomass can be burned directly for heat or converted into biofuel for electricity generation or transportation. For example, a biomass power plant utilizes agricultural residues and wood waste to produce bioenergy, providing renewable heat and electricity for local communities and reducing dependence on fossil fuels. So, what is energy management? Okay, energy management involves the strategic planning, implementation, and monitoring of measures to optimize energy use and minimize waste. It is the organization to effectively manage energy resources to reduce cost, enhance sustainability, and improve overall performance. Okay, now we take an example, okay, and understand the energy management system. Okay, so for example, XY manufacturing company, XYZ is suppose this is the name of manufacturing company. Okay, um, manufacturing company implements energy management practice to improve its operational efficiency and reduce costs. Okay, the company conducts regular energy audits to identify areas of energy inefficiency and opportunities for improvement through detailed assessments of energy consumption patterns and equipment performance. They pinpoint areas where energy is being wasted or unutilized. Based on the findings of energy, XYZ manufacturing invest in energy efficient technologies and upgrade. For example, they install high efficiency lighting system, upgrade to energy efficient HVAC system, and implement advanced control and automation to optimize energy usage in production processes. The company promotes energy conservation awareness among employees through training programs and incentives. Employees are adopt energy saving practice such as turning off lights and equipment when not is in use. Okay, optimizing equipment settings and reporting energy saving ideas. What is goals? We good efficiency, cost reduction, sustainability get with the help of energy management. Okay, for example, efficiency by optimizing energy use and reducing waste. XYZ manufacturing improves operational efficiency and productivity. Energy efficient equipment and processes require less energy input to achieve the same output, resulting in higher production rates and lower operating costs. For example, the implementation of energy efficient lighting system and equipment upgrades reduce energy consumption in the manufacturing facilities, leading to increased production output without the corresponding increase in energy cost. Effective energy management help XYZ manufacturing lower its energy bills and operating expenses by minimize energy waste and adopting energy saving technologies. The company reduce it expensive energy sources and volatile energy markets. For example, through the installation of a cogeneration system, XYZ Manufacturing generates its own electricity on site while capturing waste heat for heating and cooling purposes, resulting in significant cost savings on energy utility bills. Sustainability. XYZ Manufacturing demonstrates its sustainability by reducing its environmental footprint and mitigating climate change impacts. By transitioning to renewable energy sources, improving energy efficiency, and implementing sustainable practice, the company contributes to a cleaner and more sustainable future. For example, XYZ manufacturing invests in solar panel to generate renewable electricity for its operations, reducing greenhouse gas emission and on fossil fuels while showcasing its environmental uh, issues. This slides provides an overview of energy management, highlighting its definition, importance, and goals, along with examples and its application in real world, such as XYZ Manufacturing Company Energy Management Initiative. We take an example for understanding the energy management system. Okay, so next is energy consumption trends. Um, Energy consumption trend refer to patterns of energy use over time, both globally and within specific regions or countries. Understanding these trends is essential for policy makers, businesses, and individuals to make informed discussions regarding energy planning, resource allocations, and sustainability initiatives. There are two types of energy consumption trends. Number one, global trends, and number two, regional trend. Okay, so first is global trend. Globally, energy consumption has been steady and increasing due to population growth, economic development, and industrialization. Emerging economies such as China and India have experienced particularly rapid growth in energy demand as they undergo urbanization and industrial expansion. The transition to cleaner energy sources such as renewables is gaining momentum worldwide, driven by concern by climate change, energy security, and air pollution. However, fossil fuels still dominate the global energy maximum, accounting for the majority of energy consumption. Second is regional trend. Energy consumption patterns vary significantly across regions and countries due to differences in economic structure, industrial activity, climate, and energy policies. Developed countries such as United States have relative high per capita energy consumption rates driven by industrial production, transportation, and residential energy use. However, efforts to improve energy efficiency and promote renewable energy adoption are reducing overall energy intensity. Developing regions in Africa, Southeast Asia, and Latin America are experiencing rapid growth in energy demand as they strive to meet the needs of growing populations and expanding economies. These regions face challenges in balancing energy security, economic development, and environmental sustainability. Several factors influence energy consumption trends, including population growth, economic activity, technological advancement, energy prices, government policies, and social understanding these factors is essential for future energy demand and designing effective energy management strategies. Okay, we take an example and understand energy consumption trends. We take, for example, Teach Innovations, a global technology company, monitors energy consumption trends to inform its sustainability initiatives and businesses strategies. One second. Okay, so as global populations continue to grow, particularly in urban areas, Teach Innovations anticipates increasing demand for energy-intensive products and services, such as electronic devices, data centers, and transportation solutions. Economic growth and industrial development drive energy consumption, as seen in emerging markets where rising incomes and urbanization lead to higher energy demand. Teach Innovations identifies opportunities to develop energy efficient products and invest in renewable energy project to mitigate environmental impacts. Advances in technologies such as energy efficient appliances, smart grid, and renewable energy system play a significant role in shaping energy consumption patterns. Teach Innovations cutting edge technologies to optimize energy use in its operations and develop innovative solutions for customers seeking sustainable energy solutions. Government regulations and incentives influence energy consumption trends by promoting renewable energy adoption, implementing energy efficiency standards, and imposing carbon pricing mechanisms. Teach Innovations actively engage with policymakers to advocate for clean energy policies and aligns its businesses practice with regulatory requirements, including tools of fossil fuels and renewable energy sources impact consumer behavior and investment discussions. Teach Innovations monitors energy market trends to assess the economic renewable energy projects and adjust its energy strategies accordingly. By analyzing energy consumption trends and understanding the factors driving them, Teach Innovations develops proactive strategies to enhance energy efficiency, reduce environmental impacts, and drive sustainable growth in the rapidly evolving energy landscape. Okay, so next is energy efficiency measures. Okay, how we can measure the energy efficiency. Energy efficiency measures involve implementing practice and technologies to reduce energy consumption with maintaining or improving performance. These strategies aim to optimize energy use across various sectors, including buildings, transportation, industry, and agriculture. Okay, these steps is very important for energy efficiency measurement. Okay. Uh, Investing in energy efficient equipment and appliances can significant reduce energy consumption. For example, replacing all inefficient HVAC system with high efficiency motors can lead to energy saving while improving comfort levels. Adopting advanced technologies such as LED lighting, smart thermostat, and energy management system can help monitor and control energy usage more effectively. For instance, smart sensors and control adjust lighting and setting based on occupancy and environmental conditions, maximizing energy savings without compromising comfort or productivity. Lining operational processes and workflow can minimize energy waste and improve overall efficiency. For example, implementing lean manufacturing principles and optimizing production schedules can reduce time and energy intensive processes, leading to cost saving and environmental benefits. Engaging employee in energy conservation efforts through training awarenesses and incentive program can foster a culture of energy efficiency within our organization. Employee play a very important role in identifying opportunities for energy savings and implementing behavior changes to reduce energy waste. Implementing comprehensive energy management system enables real-time monitoring, analysis, and optimization of energy usage. Energy management system software provides insights into energy consumption patterns, identifies area of energy efficiency, and recommends actions to improve efficiency and reduce cost. Energy audits are systematic assessments of energy use and performs within buildings, facilities, or processes. They help identify opportunities for energy savings, energy efficiency measures, and track progress towards sustainability goals. Okay, for example, we take example of any company and understands the energy efficiency measure. For example, co-flantry measuring carbon monoxide. Co-friendly manufacturing carbon monoxide conducts regular energy audits to improve its operational efficiency and reduce environmental impacts. Okay, the company engaged a team of certified energy auditors to conduct comprehensive assessments of its manufacturing facilities. The audits includes a detailed analysis of energy consumption data on site inceptions and interviews with staff to identify areas of energy waste and inefficiency. Okay, then after this, based on the finding of the energy audit, co-friendly manufacturing carbon monoxides identified a range of energy efficiency measures to implement. These measures may include upgrading lighting system, optimizing HVAC systems, improving insulations, and equipment check with energy saving technologies. The company check energy efficiency measures based on their potential impact, cost effectiveness, and feasible. For example, they may start with low cost, high impact measures such as lighting upgrades before moving on to more capital intensive projects like equipment replacement or process redesign. After implementing energy efficiency measures, co-friendly manufacturing CO continues to uh, monitors energy usage and performance to ensure that targets are meet. Regular performance assessments and follow up audits help track progress, identify from expected savings, and make adjustments as needed. Okay, by conducting energy audits and implementing energy efficiency measures, co-friendly manufacturing CEO achieve significant cost savings, reduce carbon emissions, and demonstrates its commitment to sustainability, and corporate social responsibility. Okay, renewable energy systems. Renewable energy sources are derived from naturally replenished resources that are continuously available, such as sunlight, wind, water, and organic matter. These sources offer a sustainable alternative to fossil fuels and can help mitigate climate change and reduce dependence on finite sources. Okay, so we already discussed solar energy, wind energy, hydroelectric energy, biomass energy, and geothermal energy. Okay, so next is benefits and challenges of renewable energy. So first we discussed what is benefits of renewable energy sources. Renewable energy sources produce minimal greenhouse gas emission and do not finite resources, making them environmentally sustainable alternatives to fossil fuels. By energy sources and reducing on imported fuels, renewable energy enhances energy security and to supply disruptions. The renewable energy sector creates jobs and stimulates economic growth through investments in infrastructure, manufacturing, and research and development. What is challenges face in the installation of renewable energy? Many renewable energy sources such as solar and wind are depend on the weather condition. This can pose challenges for grid integration and installation. The availability and suitable of renewable energy resources vary by location, which may limit their adoption in certain regions. Developing and deploying energy renewable technologies requires significant investment in infrastructure research and development. Technological advancements and supportive policies are needed to overcome barriers to adoption. Okay, now um, we take an example, solar farm project in Green Valley, and understand the installation and each and everything related to renewable energy sources. For example, solar farm project in Green Valley, a community implemented a large-scale solar farm project to harness solar energy and reduce dependence on fossil fuel. The project involved the installation of photovoltaic panels on a vast stretch of unused land, with the generated electricity supplied to the local grid. The success of the solar farm project was attributed to strong community support and engagement. Public um, town hall meetings and discuss collaboration and by inform residents, business, and local authorities. The project's financial security, funding, and incentives from government grants, private investors, and utility partnerships. Tax and favorable finance terms were overcoming upfront cost and ensuring the project incoming feasible. Careful considerations was given to selecting appropriate solar technologies and systems designed to optimize energy productions and minimize environmental impacts. Then performance modeling help identify the most suitable locations and configurations for PV installations. Okay, so sorry. What is impacts during the installations of solar panels? We discussed the solar farm project significantly reduce greenhouse gas emission and air pollution by replacing fossil fuel based electricity generation with clean solar energy. It contributed to local and regional effort to climate change and improve air quality. The project created jobs, stimulated economic activity, and attracted investment to Green Valley. The construction phase provided employment opportunities for local, while ongoing maintenance and operation activities supported the local economy. By generating renewable energy locally, Green Valley enhance its energy security and to external supply disruptions. The solar farm project reduce on imported fossil fuels and stabilize electricity prices for residents and businesses. Next is fossil fuels based system. Fossil fuel based system rely on the combustion of coal, natural gas, and oil to generate electricity, provide heat and fuel transportation. Here, overview of fossil fuel energy productions and its environmental and economic impacts. For example, coal, natural gas, oil, coal, fire power plants burn coal to produce steam, which drive turbine connected to generators, generating electricity. Coal is used for industrial purposes, heating and street production. And natural gas is primarily used for electricity generation, heating, and industrial application. It is burned in gas turbines or combined cycle power plants to produce electricity. Oil. Oil is used for transportation fuels, heating oil, and industrial processes. It is refined into gasoline, diesel, and jet fuel for vehicles, airplanes, and ships. Okay, now we take a short example for understand the fossil fuel based power plants. For example, a fire power plant in city provides electricity to thousands of households and businesses. While the power creates jobs and supports the local economy, it also emits large amount of air pollutions, including sulfur dioxides and particulate matter, which contribute to respiratory and environmental degradations in the surrounding area. To reduce emission through technological upgrades and pollution control measures, the plant remains a significant source of air pollution and greenhouse gas emissions, highlighting the environmental and economic challenges associated with fossil fuel-based energy production. Okay. What is environment and economic impacts due to burning of fossil fuels? Okay. Anyone can give me answer this question? What is environment and economics impacts due to burning of fossil fuels? Answer only a few lines, no more. Mr. Khalid, can you give me answer this question?
Sorry, tell me again.
What is environment and economics impacts due to burning of fossil fuels?
It's
जब
loss
हम
of loss of resources.
जब हम फॉसिल फ्यूल्स को जलाते हैं तो उससे एनवायरनमेंट पे क्या इम्पैक्ट पड़ता है?
स्मोक होगा.
एंड और क्या हो सकता है इससे?
स्मोक के अलावा जो है इससे जो है बीमारियां फैलेंगी
जी
और
जी
हेल्थ
बिल्कुल.
इफेक्ट पड़ेंगे और मतलब उस साफ ज़ाहिर उससे आपको फिर रिसोर्सेज बढ़ाने पड़ेंगे, हॉस्पिटल्स यानी जितनी बीमारियां होंगी उस हवाले से हॉस्पिटल्स बढ़ाने पड़ेंगे.
ओके. ओके, तो आपके ख्याल से रिन्यूएबल एनर्जी सोर्सेज ज्यादा अच्छी है हमारे लिए फॉसिल फ्यूल्स?
यस, बिल्कुल बिल्कुल. ये एनवायरनमेंट को क्लीन रखेगी हमारी रिन्यूएबल जो एनर्जी है और
Yes.
जो मनी है या मतलब हमारे जो अमाउंट है वो सेव होगी इससे. यानी वन टाइम एक्सपेंस है, उसके बाद तो वो सेव है. और ये जो
जी
हम
जी.
नेचुरली हम बेसिकली हम इसको रिसीव करते हैं, ये जो एनर्जी है.
Okay. Thank you, Mr. Khalil. So, when we burn the fossil fuels, then air pollution creating greenhouse gas emissions, water pollution, and land degradations occur due to fossil fuel burning. Okay, so next is transitioning to clean energy. Transitioning to clean energy sources is by a range of policies and initiatives aimed to accelerating the adoption of renewable energy and reducing dependence on fossil fuels. Uh, Here we policies and initiatives promoting clean energy. We discuss some steps. For example, governments establish renewable energy standards, mandating utilize to produce a certain percentage of electricity from renewable resources. These standards creates market demand for clean energy and drive investment in renewable energy projects. Feed interests provide financial incentive for renewable energy producers by generate fixed prices for electricity generated from renewable resources. Fit encourage investment in solar, wind, and other renewable energy projects by offering stable and predictable tax creates deductions individuals and businesses to invest in renewable energy technologies such as solar panels, wind turbines, and energy efficient. These incentives reduce the upfront cost of green energy installation and accelerate their adoptions. Carbon pricing policies such as carbon taxes, cap and trade systems internalize the social cost of carbon emissions by assigning a price of greenhouse gas pollutions. By putting a price on carbon, these mechanisms emission reductions and promote the transitions to low energy sources. Government funded research and development programs support innovations in clean energy technologies such as advanced solar cell, battery storage systems, and grid integration solutions. These investments drive technological advancement, reduce cost, and enhance the clean energy options. Okay, due to this transitioning or to clean energy, different challenges we face. For example, renewable energy sources such as solar and wind are intermittent and variable, posing challenges of for grid stability. Integrating large-scale renewable energy into exciting grid infrastructure require upgrades and investment in storage, transmission, and demand response technologies. Storage technologies such as batteries and pump hydro are essential for storing renewable energy and providing backup power during periods of low generation. However, cost and technical limitation of energy storage system remain significant challenges to overcome. Changing political landscape and shifting policies can create uncertainty for clean energy investment and regulatory framework policies and inadequate support for renewable energy might hinder market growth and investment in clean energy projects. The transition to clean energy may disrupt traditional energy industries and require retraining of the workforce, ensuring a just transition for workers in fossil fuel dependent sectors such as coal mining and oil refining is essential to mitigate social and economic impacts. What is opportunities in transitioning to clean energy? The clean energy transition presents opportunities for economic growth, job creation, and innovation. Investing in renewable energy projects, energy efficiency upgrades, and green infrastructure can stimulate local economies, attract investment, and create new employment opportunities across sectors. And energy sources and reducing dependence on importing fossil fuels enhance energy dependence and security. Investing in domestic renewable energy resources mitigates supply risk and reduce to geopolitical tensions and market breaks. Transitioning to clean energy reduce air and water pollution, mitigates climate change and impacts, and improve public health outcomes by reducing emission of harmful pollutants and greenhouse gases. Clean energy technologies contribute to cleaner air, water, and ecosystem benefit human health well-being. Clean energy technologies drive technological innovation and enhance global investing in research, development, and development of clean energy solutions, innovations, ecosystem supports advanced manufacturing industries and positions countries at the forefront of the clean energy transition. Okay, so next we discuss smart grid and energy management. Uh, so we meet after 5 minute break. Okay. Okay, so now our topic is next is smart grid and energy management. Smart grid are modern electricity network that integrate advanced communication control and monitoring technologies to enhance the efficiency and the sustainability of energy distributions. Smart grid improve grid by detecting and isolating faults, predicting and preventing outages, and facilitate rapid restoration of service. Advanced monitoring and control enable utilities to respond proactively to grid disturbance and minimize downtime for consumers. Smart grid optimize energy distribution and utilization by balancing supply and demand in real time, reducing losses in transmission and distribution, and integrating renewable energy sources and energy storage system. They enable utilities to manage peak loads more effectively and reduce energy system waste stage. Smart grid supports the integration of renewable energy sources such as solar and wind by providing grid stability services, manage generation and facilitating directional energy flow. The enable consumers to generate, store, and sell excess renewable energy back to the grid, promoting energy production and grid. Smart grid empower consumers with greater and control over their energy usage, allowing them to monitor energy consumption in real time, optimize energy use during off-peak hours, and participate in demand response programs. Consumers can make informed discussions about energy efficiency measures and renewable energy investment, leading to cost saving and environmental benefits. Okay, now we take an example and understand the smart grid and energy management. For example, utility company X implemented a smart grid system to optimize energy distribution and enhance grid for its customers through real-time monitoring and control of grid operations. The smart grid system uh, detect and resolve the power faster, reduces energy losses during transmissions and distribution, and integrates renewable energy sources into the grid. Customers benefit for improve lower energy bills and greater control over their energy use, demonstrating the effectiveness of smart grid in optimizing energy distributions and management. Next is energy storage solution. Energy storage energy storage play a critical role in enhancing the and flexible of energy system by storing excess energy during periods of low demands and releasing it when demand is high. So there are different types of energy technologies. Energy storage technologies encompass a diverse range of solutions for storing and releasing energy in various forms. Okay, here we discussed some types. Battery energy storage system. Battery energy storage system store electrical energy in chemical form and release it as electricity when needed. Lithium, for example, lithium-ion batteries are widely used for grid scale and distributed energy storage application due to their high energy density, fast response time, and long cycle life. And pumped storage hydro system use energy to pump water from a lower reservoir to high reservoir during off-peak hours. When energy demand increases, water is released from the upper reservoir to flow to turbines and generate electricity. Flywheel energy storage system store kinetic energy into a rotating mass and release it as electricity when needed. They offer fast response times and high power density, making them suitable for application requiring rapid energy discharge and frequency regulation. And thermal energy storage system store heat or cooled energy in materials such as molten salts, phase change materials, child water जो होता है. They release stored energy for heating, cooling, or power generation purposes, improving energy efficiency and reducing peak demand on heating and cooling system. Compressed air energy storage by compressing air into underground or pressurized vessels when energy is needed. The compressed air is expanded and used to drive turbines to generate electricity. And hydrogen energy storage. Hydrogen can be produced through electrolysis using renewable electricity and stored for later use in fossil cells or combustion engines to generate electricity or heat. uh, Energy management software. Energy management software provides comprehensive tools and analytical for monitoring, analyzing, or optimizing energy consumption and performance across various sectors, including buildings, facilities, and industrial processes. Okay, here overview of software solution in energy management. For example, monitoring and reporting. Energy management system platform tracked real-time data on energy usage, demand, and cost from meters, sensors, and building management system. They provide uh, reports and alerts to track energy performance metrics, identify trend, and communicate insights to holders. And the second is energy analytics. Energy management system platform advanced analytic and machine learning algorithm to analyze energy data, detect and identify opportunities for optimization. They provide insights into energy consumption patterns, load profiles, and equipment performance, enabling informed discussions, making, and proactive energy management strategies. And the next is forecasting and prediction. Energy management system platforms use historical data and predictive modeling techniques to forecast future energy demand, consumption, and cost. They help utilize businesses and institutions participate energy needs, plan resource allocations, and optimize energy and production strategies. And next is demand response and load management. Energy management system platforms support demand response programs by enabling the automating the control of energy consuming devices such as HVAC system, lighting, and industrial equipment. They help utilize and grid operators manage peak loads, reduce energy costs, and enhance grid through load sheeting and demand side management. Energy efficiency optimization. Energy management system platform identify energy efficiency opportunities, recommend optimization measures, and track performance improvements over time. They support energy adherence, communication, and continuous to maximize energy savings, reduce operating costs, and achieve sustainable goals. Okay, integration with building automation systems. EMS platform integrate with buildings automation system to control and optimize energy consuming devices such as HVAC systems, lighting control, and smart meters. They enable control and automation of building operation, improving energy efficiency and occupant comfort. Okay, for example, we take example for understand this energy management system software. Organization acts successful energy engagement implementation demonstrates the effectiveness of adopting a comprehensive approach to energy management, including energy adherence, efficiency measures, employee engagement, and technology adoption. By energy efficiency and sustainable organization acts achieve significant cost saving, reduce environmental impact, and improve operational performance, setting an example for other organizations to follow. Okay, so next slide is future trends in energy systems. The future of energy system is shaped by ongoing advancement in technology, innovation, and market dynamics. Here are some emerging technologies and innovation driving future trends in energy systems. For example, renewable energy integration, continue advancement in energy, renewable energy technologies such as solar photovoltaics, wind turbines, and battery storage, or greater integration of renewable energy into the grid. Innovations in material science, efficiency improvements, and cost reductions are marketing renewable energy sources more competitive and scalable. Energy storage solution break in energy storage technologies, including advanced batteries, flow batteries, and hydrogen storage, are enhancing the grid flexible energy storage solution, enable better management, renewable energy generation, support peak load management, and provide backup power during outages. Smart grid technology. Smart grid technologies such as advanced metering infrastructure, distribution automation, and demand response system are transforming energy infrastructure and operations. These technologies enable real-time monitoring, control, and optimizing of energy flow, enhance grid efficiency, stability. Distributed energy resources. Distributed energy resources, rooftop solar panels, okay, microgrid, and electric vehicles, and reshaping the energy landscape by energy generation and consumption. Innovation in DER management system, grid edge devices, and peer-to-peer energy trading platform are improving consumers to participate in energy market and optimize their energy usage. And artificial intelligence and machine learning, AI and machine learning algorithms are energy management and optimization, enabling analytical control and adapting discussion, making AI power energy management system optimize energy usage. Predictive equipment systems optimize energy usage, predictive equipment, and optimize energy strategies, leading to greater efficiency and cost saving. Example of power plant for understanding the energy system and management. Okay, so in this slide we take a example of power plant and understand overall the energy management systems. A power plant is like a GAN factory for electricity. An energy management system acts as a brain and conductor of this factory, optimizing its performance. Okay, for example, monitoring power flow. Imagine a complex network of pipes carrying water throughout the plant. The EMS constant monitors the pressure and flow at different points. It's like having pressure gauge and flow meters on every pipe. Based on the data, the EMS can identify areas where energy is wasted. Maybe a pump is working harder than needed, or a wall is slightly leakage. The EMS can then make adjustment to optimize power generation. It might tell the control system to slightly reduce the power output of a specific generator or adjust the setting on the transformer. It's like having a constant fine tuning the machinery or peak performance. The EMS can also analyze trend and predict potential issues. If a key component shows signs of wear and tears, the system can alert the operator for preventive maintenance. It's like having a mechanic who can foresee problems before they cause a breakdown. A power plant need to match the electricity they generate with the ever-changing demand from homes and businesses. The EMS can communicate with the grid and adjust power output according. It's like having a conductor who ensures the power plant play in perfect harmony with the audience. Okay, so this is the example for understanding the overall energy system and management in the simple world. Okay, so this is the last slide. Okay, so any question? Any question? Okay. Okay, the session is end.